Good evening, and today we are going to discuss the remaining matrix algebra applications in the machine learning. The remaining applications means the names of it are recurrent neural networks (RNNs), recommender system and matrix factorization method, graph theory and network analysis, support vector machines, kernel methods, non-negative factorization method, natural language processing method, and image processing regularization. There are totally 9 applications we are looking into this ML, which are applications of matrix algebra. In the recurrent neural networks, RNNs, if you look into it, it involves sequential data. Matrix operations are used to process sequences over a time, such as for hidden state updates. Examples, if you take into consideration, text generation. So, if you give a input text, it will generate a sequence of new text. So, with the help of RNNs. So, it is used to create a model that generates the text in the form of sentences or paragraphs. And it is and comes under the topic of generative AI. And matrix factorization and recommender systems. This is another application. SVD is a matrix factorization technique used in ML applications. In collaborative filtering and recommender systems, matrix factorization techniques like SVD or alternative least squares are used to factorize user item interaction data or matrix into latent factors. So, in this way, user specific recommendations also it will perform and use it to make personalized recommendations. That's what we can say. And very, very useful topic. And the giants in the market analysis like Amazon and others are using these personalized recommendations also, Netflix, etc. Graph theory and network analysis. Graph-based machine learning models are often rely on matrices to represent the graph structure and perform operations like matrix multiplication for graph convolutions. So manipulating adjacency matrices or graph Laplacians for tasks like community detection and link predictions. So the graph Laplacian is a mathematical concept used in graph theory and spectral graph theory to analyze the properties of the graphs. It is a very, very useful application, particularly in terms of social networking and other applications. And another application, what we look at is support vector missions. In the support vector missions, if you look at, uses matrix algebra for solving dual optimization problem in order to find the hyperplane that separates the data points into different classes. If you look at, this is seems to be a line which is able to separate two different classes. Now, if you look at, this is a plane, hyperplane, which separates to the maximum extent the different class labels or classes, what we can say. This is in R2 plane and this is R plane. That means 3-dimensional and this is a 2-dimensional one. These are the references we consider for these diagrams. And kernel methods, support vector missions and kernel methods use matrices to compute the kernel functions which are used to map the data into a higher dimensional feature space using matrix operations. If you look at in the previous case, this is a 2-dimension. I am mapping into the 3 dimensions so that I can able to separate the data or the class labels data in a better fashion. So there are different types of kernels are there. One is linear kernel that computes the dot product of the two input vectors. Coming to the polynomial kernel, raises the dot product of two input vectors to a power, and whereas Gaussian RBF kernel used in SVMs. So this is what we are going to look at, the applications of kernels. So that maps the data from lower dimensional to higher dimensional feature space based on matrix operations. That's where the whole importance of matrix algebra is coming, and non-negative matrix factorization. So this is used for feature extraction. So apart from data factorization, and it is used particularly in image processing to decompose the images into their constituent parts, such as faces, objects, and textures. And even it is useful in segment the medical images to identify different tissues or organs. So it has a lot of applications, I can say. And text analysis also, to extract the topics or to extract the similar text documents, etc., and identify clusters of similar documents and summarize the documents. So which is the part of generative AI. So non-negative matrix factorization. So these have a lot of applications in the latest domains or the areas. So natural language processing. So in NLP, tasks, word embeddings, and language models so involve matrix representation of words and sentences. So techniques like word to vector use matrix factorization to learn word embeddings. So this is a powerful area which comes under part of AI. So we are using currently, the industry is using heavily the NLP. So language translators are various kind of applications, the summarization of documents, so etc. We can use the NLP. And topic comes under image processing. Image processing heavily use the matrices. Even to represent a single image, we are going to make use of a matrix with pixel values. Suppose an image is consists of 250 by 250. That means it's matrix consisting of the elements of pixel values of 250 by 250 size. The matrix operations applied to perform these tasks are filtering, edge detection, feature extraction. So all these kind of tasks we can do by manipulating the matrix based on the required operations. And the last technique, what I can suggest is the regularization. So techniques like L1 and L2 regularization involve matrix algebra operations to add penalties to the loss function so that we can control the model complexity. And it is a technique used in ML to prevent overfitting also. And in the summary, I can say matrix algebra is a fundamental mathematical tool that underlies ML algorithms and techniques. And understanding and efficiently manipulating matrices are essential skills of machine learning practitioners. To enable the implementation and optimization of various models and algorithms, one has to be thorough and use matrix algebra and matrix operations. So, and thank you one and all. And please do subscribe. And any doubts you can raise in the link below.